One important question that comes up, knowing that TCP is a reliable transport protocol and handles lost segments, is that how does TCP sets the timeout for lost packets? Remember that timeout value starts with estimating round trip time. However, round trip time varies based on network state. If we set the timer value too short, premature timeout will cause unnecessary retransmits. And if we set the timer value too long, the reaction to loss will be too slow. So, how do we estimate RTT despite the changes? We can measure a sample RTT using a segment sent time till its acknowledgement is received. Then, use weighted averaging for historical aging of the average over the sampled value. We can use a weighting coefficient, alpha, to determine weight of the historical and new sample values. The formula will be estimated RTT equals 1 minus alpha times previously estimated RTT plus alpha times the new sample RTT. For example, a typically used value of alpha equal 0.125 would yield the RTT estimated shown in the figure with black line, using the sample RTT values shown in the blue. Now that we have an estimate of the RTT value, how to use that to decide timeout? A way to do this is considering the deviations in the RTT value as well. The larger the variations in our RTT value, the larger we have to choose our safety margin. We can find the deviations using a similarly weighted average formula, with beta deciding the weight of the historical value to the changes of the estimated RTT in the last sampling. The typical value used for beta is 0.25. We can, then, to calculate the timeout interval, add to the estimated RTT 4 times the deviations of the RTT as the safety margin to help avoid early timeout.